Hello, my name is Stephen Richardson, and this is the second assignment for GIS 512. So the article that I found was entitled A Comparison of Sentinel-3 OLCI and Sentinel-2 MSI Derived Chlorophyll A Maps for Two Large Italian Lakes, and this was by Cazzaniga et al. And basically the purpose of the study was to explore two different sites throughout the Italian landscape, and of note is both these sites varied over a climactic gradient. So the first site, Lake Garda, is the northernmost lake, still centered in the Italian landmass as Italy's largest lake, and came in at over 370 kilometers squared. And it's oligomictic in nature, which means that the water column is really well mixed, and there's little turbulent events throughout the season that mixes this water body. Lake Trasimeno, in comparison, is less than half the size of our first lake, and it comes in at 124 kilometers squared. It's a relatively shallow body of water with a max depth of 6 meters at its deepest point. There's a variation of land use in the surrounding area, from slightly developed to mostly rural, as well as some agricultural uses and livestock, namely bovine. And it has been noted that this site experiences prevalent phytoplankton blooms season to season. So two sensors utilized were the Sentinel-2 MSI, or the multispectral instrument. There's a 5-day visitation times on this instrument, 12 bands collected each time, with a wavelength among those bands ranging from 443 to 2,201 nanometers. Spatial resolution for the Sentinel-2 is 10 meters at the surface. By comparison, the Sentinel-3 OLCI, or the Ocean and Land Color Imager, has a 2-day visitation times, and that was at the time of the study, or at least for the images that they utilized for imaging. From 400 to 1,020 nanometers at the surface. So the resolution is, as you can see, 300 meters at the surface when compared to 10 meters at the surface with the Sentinel-2. So you have to take a corrections and modeling approach when gathering this data and processing it. Most notably the atmospheric corrections, taking into account many variables such as aerosol optical thickness, columnar ozone concentration, and columnar water content. And they also applied a biooptical model, or the BOMER model, which is a biooptical model-based tool for estimating water quality with remote sensing. And basically looks at the inherent optical properties that you gather from in situ measurements to get the spectral slope through absorption in laboratory measurements. This here, and basically they compared the in situ measurements with the remotely sourced data and found little variations between the two. They follow pretty much the same pattern throughout, although there is an overestimation from actual in situ measurements with respect to chlorophyll concentrations. This next image basically compares the Sentinel-2 and Sentinel-3, so the MSI and OLCI sensor arrays, and basically tried to compare each of the images that were collected. There were some overlap from the days that they were able to collect, and obviously they're not going to match up specifically, but we're trying to get as close to one another for the available images that were there. So basically, in summary, the author finds that there are some agreement between both the OLCI and the MSI. Maps reduced, but there were slight overestimations when moving from the MSI to OLCI. And to really make this work, it's going to take day-to-day updates for aerosol levels at each site, as well as other parameters. And the authors note that this is pretty applicable for larger scale systems, but not really good for smaller water bodies, such as the ones that I'm interested in around Wake County. All right, thank you for your time.